Product of powers and power of powers. So let's take a look at some rules on how we can work with our powers and how they work. We'll do one at a time here. So the product of powers. Product of powers meaning I'm multiplying two powers. I've got two powers and I'm multiplying them together. To multiply powers with the same base, that's super important. They have to have the same base. To multiply powers with the same base, add their exponents. So 4 to the second times 4 to the third. That's basically 4, and we're going to add the 2 and the 3 together to get 4 to the fifth. And if you think about that, that makes sense. This is 4 times 4. This is 4 times 4 times 4, which gives me 5 of them all together, so it's 4 to the fifth power. Notice I'm keeping the base. Since this base is both 4, I'm keeping that base of 4, and I'm leaving it the same. Because notice when we get to the end there, I have 5 factors of 4. So I don't have a factor of 16. It's a factor of 4 that we're multiplying repeatedly there. All right, let's simplify each of these expressions. So 6 to the second plus times 6 to the fourth. Our shortcuts, I'm going to keep this 6, and I'm going to add my powers. So 2 plus 4, so that gives me 6 to the sixth. Next one, negative 1/2 to the third power times negative 1/2 to the sixth power. Again, I'm going to keep the base, since the bases are the same. It's the only reason I can use this trick. I'm going to keep the base, and then I'm going to add the exponent, so I get 3 plus 6 gives me 9. In my last one, I have m times m to the 12th. Please remember that this m, there really is an exponent there. It's that imaginary 1 that appears all sorts of places, but we don't write it. We have a 1 there, so this is m to the first times m to the 12th. So we end up with m to the 13th when we add those exponents, keeping the base. All right, and our next property that we have here, the power of a power. This is a power on top of a power. We're kind of nesting them. It's kind of like our nesting dolls in our last example. To find a power of a power, multiply the expressions. So notice here I don't have two bases. I have 4 to the second, and now this is the base with the third power. So if I really think about what's happening here, I'm doing 4 to the second times 4 to the second times 4 to the second. I'm repeating that 4 to the second over and over again. Now if I go back to the last rule, 4 to the second times 4 to the second times 4 to the second, I would keep the 4, and then 2 plus 2 plus 2, which would give me 6. Shortcut way to do that is to multiply the 2 times the 3, and I come up with 4 to the 6th. So this is a power of a power. All right, so let's apply this in some of these. We're going to simplify these. Y to the second times 4 to the fourth power. So this is y to the second times y to the second times y to the second times y to the second, which if again I go back to my other rule there, I'm going to keep the base and add all of those exponents. We get y to the 8th. But again, the shortcut here, I can multiply this 2 times 4. All right, here I have negative 4 to the third power. So my negative 4 is in parentheses because I want to keep that negative as part of the base. To the second power, so I'm going to multiply these two exponents, keeping the base. So I have negative 4 to the sixth power. And my last one with a variable in there, I have w to the fifth to the third power. So again, I'm going to keep that w, and I'm going to do 5 times 3, which gives me 15. So our two rules dealing with powers, product of powers, I want to keep the base and add the exponents. And power of powers, I'm going to keep that base, but I'm going to multiply the exponents together.